All right, hello everybody, and welcome to Malware Club. So today we have a couple of different topics that we're going to cover. I don't have any announcements, so I'm just going to introduce the speakers tonight. So we have Tarek, who is going to be presenting on like advanced malware techniques as well as shellcode. So Tarek is a master's student, and he's also works at the Verona lab with Dr. Brizendine. And then after Tarek, we're going to have Evan, who's the VP of Malware Club and also a master's student at DSU. He's going to be presenting on the Pegasus malware, and as well as talking about the NSO Group who developed the Pegasus malware. So that is all for me. So I'm going to hand it off to Tarek whenever he's ready.
Thanks, Orion. Can you hear me?
Yes, I can.
Okay. No, that's not. Hello, everyone. Since I have only 30 minutes, or maybe 35 minutes, I'll just be quick. So today I'm gonna cover a little bit of some of the techniques of the malwares, like maybe I talked about some of them like last semester. I'm gonna cover other techniques as well. Hopefully I can cover everything. Also the shell coding part of it. That's gonna definitely be like more than 30 minutes. So first of all, a little bit of an introduction about remote administration tools. They're basically written in C or C++. That's why you guys are studying C programming here at DSU, which is very useful. So the dropper or the malware itself, it's mainly written in C. And the C2 or the command and control server is written in Python. It doesn't have to be in Python, but just for ease of use, you can write it in any other language you want. But since it's from your side, you can write it any way you want. Python is preferred. And to store the database of all the connections and all the things you're interacting with the victim, you need some kind of a database. You don't have, again, you don't have to use MySQL as a backend database. You can use Postgre, SQL, or any other kind of database. You can also have a web control, like a graphical interface for using HTML or PHP. This is not necessary, but sometimes it gives you access to your controlled devices easily. You don't have to keep typing commands and stuff like that. The command and control techniques so the first thing that we're discussing is how you send the traffic back and forth between the dropper or the implant and the C2. One is the beaconing. The beaconing is just to tell your C2 that this certain device is infected and I'm alive, like the beacon just telling the C2 that I'm here if you want to send any commands or anything. I'm ready to receive them and execute them. This also gives the C2 information about the target, like what kind of operating system it's using, the CPU, the architecture, the memory, and more. Because sometimes when they infect the target, this target could be used for mining. So that's why it's important to know if the CPU is or GPU is strong enough to do some mining in the background. The dead drop is basically you're using, or the malware is using a third-party website, like you can use Gmail or Google, Twitter, any other website to interact with the C2. So the C2 is going to send commands through the Gmail or Twitter or whatever. And also the malware is receiving those commands through a third-party website. This is very stealthy, but requires more coding, of course. Like some people I've seen in the past, they put some upload a picture or like an image on Twitter, and the pixels of the image has the command or the output of the data. There's also Gmail. You can interact through the Gmail or the inbox. You can send an email to yourself with the commands, and also the agent will reply back to the email as an email in the inbox. This is very stealthy because it's encrypted using SSL. And also, if you look at it from the intrusion detection perspective, you see traffic go into the Gmail, which is pretty common. It's like you can suspect that someone just opening his inbox or his email. Long polling is another technique that's used with a web server. The server side will keep the connection long enough to receive all the data, and then we'll close it later, versus sending back and forth, start the connection and close it, and then wait for another packet and receive it, and so on. This will make the data or the packet being sent from the agent to the server less. So instead of sending like 10 packets, it'll be like 2. Port knocking. This is if sometimes the malware will want to hide the open ports used for C2 to control the infected host. So it will wait for a sequence of connection or packets to a closed ports. Let's say 5 closed ports. You make a connection to those 5 closed ports, like in sequence. Once the sequence is complete, then you get the source IP, which is the C2 IP, and you allow it through the firewall. Like, hey, can you allow this IP address through the firewall on this port? So this is also very good because you don't have to open the port for every single IP. The protocol is being used, TCP UDP and ICMP UDP. Sometimes there's being used for DNS command and control, but you can actually, it makes the traffic suspicious. If you look at the IDS or any intrusion detection, you can look at the DNS traffic, you can suspect it right away or spot it that this is sketchy traffic or looks weird. ICMP, you can also use that to send your traffic, especially the beaconing. You can craft an ICMP packet, which is used for pinging, and send data back and forth to your C2. Those are some of the examples of the C2 out in the wild. Cobalt Strike, Interpreter, which is the Metasploit, Copy, Empire, Covenant. Of course, there are much more out there. Stages. I would say that stage 0 and 1, they're the most important. And the reason why stage 0 is the initial delivery of the target of the implant itself. So you need to bypass the antivirus because if it gets detected, that's it, it's over. Once you bypass the defenses, and then you get to stage 1, which you want your implant or this malware to be persistent on the system. Because if the target reboot his device, then you lost the connection to your implant, and it's not very easy to get back again, to get it online. So stage 0 and 1, they're very, very important. Stage 2 and 3, you don't have to do them. They're just basic, more data. You gather more information about the target. You do like some lateral movement through the network. So it's not very necessary. It's an additional functionality to your malware, but you don't have to use them. The first malware techniques or the basics of malware is executing a command on a target. Once you control a target, you need to execute some basic commands like CMD commands. So I was working on a project 2 years ago as part of a research here at DSU, and I was just testing and playing around and seeing that how from the intrusion detection we'll see the traffic. I had the Kibana or the Elasticsearch. You probably took this in your defensive security course, maybe not yet, to see how the traffic appears from the logging side. So this is from Elasticsearch, and sysmon is gathering all the logs and sending that to Elasticsearch. And here, if you look closely at the line that I'm the c2.exe, this is the actual implant, or the one that I was creating. And if you look above a little bit, go up in the middle of the screen, you see the command line. The command line that I was using is who am I. You see cmd.exe/c who am I, which is not good. If you see this from the intrusion detection or you're working as a security analyst, if you see something like this, this is right off the bat, this is a malware. There's someone who's trying to control the target. So how do you solve this? You can create a different process for the cmd.exe. So the process will be cmd.exe, and all the commands like the ipconfig, who am I, all these kind of commands will be coming from the cmd.exe versus the implant itself. In order for you to do this, you can just use the create process API, the Windows API. And here I'm just showing that the command is coming from cmd.exe, which is still not good, because also if you take a look at it, you can still see the who am I at the top as a command line, like someone is executing who am I through cmd.exe. This is through the winlog beat. This shows also the file itself and the destination IP and the destination port, which is 8080. And it shows that c2.exe is making the connection back using this port. And in order for us to hide this a little bit, we need to use something called process hollowing, which is you hijack a different process. You can create a process, or you can inject a shellcode into a running process. You can inject it with a shellcode, or like the shellcode could be something like Meterpreter or reverse shell, or you can create your own shellcode and inject it into a different process and make this process as a zombie process and control it. Make this one to be the one that's sending the traffic versus the implant. So here, this is just the steps. I don't want to go through like all of them because I still need to go through a lot of other stuff. But sure. So the idea is you create a process, like I was using in this example. I was using chrome.exe because I want to make my traffic as a legitimate traffic. So I get the default browser path on the system. This browser could be Chrome, Firefox, or Internet Explorer, or anything else. Once you get the path, you can start this process in suspended mode, and then we can control it now by loading a DLL file, which is the WinINet, the one that I'm using to get all the web requests and response from. The WinINet is a library that you can use to get all these functionality. You load the DLL inside the Chrome's process, and then you can control and get the APIs, the Win APIs from there. This is an example of the Internet Open, which is the very first API that you will see when you make a web request to using the WinINet.dll library. This is what it looks like, the Win API at the top, and this is like the shellcode. See a bunch of zeros to match the nulls, and then move ECX like a dead code. The reason why I'm doing this way, because when you're writing a malware, you have total like all the control you need versus you're writing a shellcode. When you write a malware, you can just do something like this. Like we need a pointer to be in ECX. You can just put a dead code or a dummy hex there. And then later inside your C++ program, you can replace this dead code with the actual pointer using something like memcopy. So here I'm also using the virtual address of Internet Open. I move that into EBX, and then I call EBX. Of course, this shellcode is not usable until you replace this dead code with something else. This is the Internet Connect A, which is the second API. Same idea. Here I have the port 8080 and then a pointer to the IP address. this IP address also is loaded in the Chrome's memory space. So once you do that, you get the pointer of that and you put it in one of those registers to use it. Here we're replacing it. Once you're done this, you replace those bit codes with something like memcopy. So here, if we assume that agent or the agent pointer starts from +9, like the shellcode +9, so you count 9 bytes, and then this is how you replace those dead code with the pointer of the agent and the pointer of the open, which is the internet open address, and the 4 is just the 4 bytes you want to replace, only 4 bytes. So here, this is another example. Like after you do this, I inject it into a Chrome's application or the process. I start the process, I inject all this shellcode in it. Here it says it comes from Chrome.exe, which is very good. So Chrome now is the one making the request. So now I'm gonna go to this virtual machine. I don't know if you guys can see it or not. So I have an example here of this Chrome.exe. So this one, I'm just going to start debugging. Okay. I don't know how to do it here. It's not clear enough. I'm just going to stop the debugger. This is the create process API. It's not created yet, but if I just do continue, now I passed the create process API. If I open something like process hacker and scroll down, you can see Chrome here. I don't know if you guys can see it or not. Chrome.exe. I'm sorry, here. Proc inject. Underneath it is Chrome.exe, which is not good, because if you open process hacker and you look at this, you see like, oh, this malware creates a Chrome. There's another thread coming from this one, which is very suspicious. It's probably using process hollowing or something like that, right? That's not what we want. Or, I mean, from a malware author's perspective, this is not what you want. Here comes another technique, is spoofing the parent process ID. So here, same thing, the create process A or create process, you can still use the same API, but there is another argument here. It's called extended startup info _ present. It's like a structure of more or necessary information about the process. So you're telling the API like, hey, I have more information about this process. This extended startup present will take all the information, from the info, that startup info that we should have created earlier. I can show you that as well. So the idea is we get a process ID of any process that we want to spoof, like here is explorer.exe. And we initialize the proc thread attribute, which has all the attributes that we will modify later. Then we open the process explorer.exe. We get all the attributes of this process, and we copy that to our own process using this flag or extended startup info _ present. So if we head back to the other example here, this is another example I prepared for this one. I'm just going to start debugging. I think it's taking a little bit of time. Okay. think the laptop is just being very slow now, like Zoom and two virtual box. And so now here we hit the breakpoint again, create process. If I click continue again to hit the other breakpoint, which is the process will be created. If we look down here, the test.exe, there's nothing beneath it. The chrome.exe here is coming from, if you scroll up a little bit, from the Explorer. So if we expand this one again, go down, here the chrome.exe spoof the parent process of Explorer. So if you're watching the test as a malware, you're not going to see anything coming beneath it, so it's safe. And this is the code that I was talking about here. Like, I have a function called getPID. I give it the process that I'm looking for, explorer.exe, and then the rest of the structure that I build, the attributes. Yeah. So this is something else also. If you're, now we know how to spoof the process ID or how it's done. Also, when you execute a command, still it's going to show as a cmd.exe, even though you create a different process for cmd.exe, because you don't want it to be the same process. But how to avoid that? Well, in order to avoid that, you have to create your own API or your own functions using native APIs to do that, like ipconfig or whoami. Microsoft has many functions that you can use to do the same thing without touching the ipconfig.exe or whoami.exe. At that time when I created this, there was no detection rate. The other one, the Chrome, that hijacking one, was the one that got flagged by one antivirus. Something else also, if you're writing your API names or like something like virtual alloc inside the malware, then you need to hide the string name. Like this example, I'm using type-def to create like the prototype for the structure, which is virtual alloc t. It's a Win API. And then we give it all the structure here, like LP void, IP address, the W size, and so on. And then we use that here down there, and we change the name. To my new valloc. You can use you can call it anything you want, but we're still using virtual alloc API. Now the kernel32.dll still is a string inside the malware. To hide that, you can convert that into a base 64, and you can have a function called, like, let's say base b64 decode, and you give it the base 64 to decode that. This will hide it from appearing then. Now you don't see the kernel32 or user 32.dll anymore. I'm using base 64 encoded version of it. Sometimes the antivirus, like let's say the Defender or something, will place some hooks on those APIs, like to make system calls. So eventually, when you're making an API call, it will go to the system call and the NTDLL to make this API happen, like this API call happen. So a bit Defender, for instance, will put a jump there, not on at all the APIs, but some of them. It will just have a list of APIs that are being used by malwares and put a hook there, or it's not necessarily a hook, it's a jump instruction in the assembly. Once you hit this jump instruction, it will go somewhere else in the code, probably will go to the antivirus memory space, do some checking there, and then it will be sent to the original address. Two techniques to bypass this one. One is called Hell's Gate, and the other was Halo's Gate. Halo's Gate is like a twin sister of Hell's Gate. Hell's Gate is you parse the in-memory module list from the NTDLL file to get all the syscall numbers and you replace all the hooks, which is, I'm gonna show you guys what it looks like. This is an API function in the kernel level, like NTDLL. It's called create thread EX. If you look there, there's a jump, which is not usual. I mean, you shouldn't have that there. This jump, it will go somewhere else. This is a hook from the antivirus. And then once it's done, it will come back to continue execution. It will go to the original address that it was supposed to go to. The other one, the other screenshot at the bottom, it's unhooked, a different API. It's called int allocate virtual memory. It starts with move RCX into R10, but the other one, it doesn't. It starts with jump. So what the Hell's Gate is doing is replacing those jump instructions with the actual syscall number that it gets from parsing the NTDLL in-memory order module list. Hell's Gate, it's a modified version of the Hell's Gate, which is basically will go up and down. Once it finds a hook instruction, like a jump instruction, it will go up or down until it finds an unhooked API. Once it's found, since the syscalls are using in incremental by 1, so they are in order, it will find an unhooked one and then it will go down increment 1 and replace this hooked instruction. So same concept, if it goes down, finds unhooked 1, it will decrement 1 to go up. When it comes to shellcode developments, something to be aware of is how to write a small shellcode. Using, like, you don't need to use unnecessary bytes when you can. This is an example of some of the bytes and the equivalent, like the size of the bytes, like move EX1, this is 5 bytes versus 3 bytes, XOR EX, and then increment EX. Same thing for swap, like if you want to swap a register, this one is 6 bytes versus if you do 2 pushes and 2 pops is 4 bytes, and the other one is exchange is only 1 byte. Same thing here. You can move the value 44 in EX, but you can also use the smallest register to do this, which is AL. It will only give you 2 bytes, and you get rid of the no bytes as well. You can use the increment with the extended registers only, because if you use inc or increment on something like AL, thinking that it will give you less bytes, it actually give you more bytes, like 2 bytes versus 1 byte. Same thing here for the move ESP and the rep move ESP gives you like 1 byte, rep move ESP 2 bytes, load ESP 1 byte. Same concept here. API calls, as we've seen, like you can just use call and then the API from the shellcode that I was showing you. You can call the register, or you can call in the actual address itself, or you can call a pointer of the address, like the word pointer. But this might have a problem if you're running antivirus, because some antiviruses, they will keep a track of all the API lists through the addresses, like the hex address of the API. And if you're trying to make a call to this API, it will track this as something suspicious. So we can also simulate the API call using assembly. Like you can use here, jump from label, first instruction is jump to label 2, and from label 2, we call label 1 up there. The reason why we do this is because we want to push the XOR EBX CBX instruction. This is the return address. We want to push that on the stack, but we don't want to call our function yet. We push that on the stack, and then we jump to label 1, and from label 1, we do jump to EAX, assuming that the API is in EAX. So we did not make a call into EAX, but we still push the return address on the stack, and we jump to EAX.
Oh no, the funny thing is, like that you'll pull it up.
Another way is to hide the API address, like this one, for instance, the virtual alloc. The first address of virtual alloc and most of the other APIs, it's move EDI, EDI. So garbage instruction doesn't mean anything. So we don't need this instruction. We can just do increment ex1 and increment it again, and then call ex. If we do this, we'll be calling the push EBP itself, which is the address of 3C2. So once we do this, the or the antivirus doesn't know the address because it will be tracking EX, and EX here doesn't match the original one of virtual allo. If you open this in something like X32 debug or WinDebug, it usually shows you the address of the API equivalent or right next to the register. But if you do this way, it will show you nothing. There's nothing there. I think that was it. I think I have a few more minutes to demo like the C2 that I built before. Assuming that it would work fine. So this is like the beacon connection that I was talking about in the first few slides. It's sending a beacon like, hey, I'm alive, just to know the IP address. And I just gave it a name like an agent and just random value. Now, if I do list agents, it will give me a list of all the agents, some memory, and the operating system. This is also just hard-coded data just for the purpose of this presentation. And if you just go like do like go mx so this will use something that I use HTML and PHP. Like I put the command, I encode it into HTML page, and I make the dropper to read this shellcode and decrypt it, and I put the key in an image file. It will parse the image and get the key from a pixel, and through the key it will decrypt the command and execute it and send it back to me. This who am I, it's not using whoami.exe, it's using a built-in function inside my malware. Same thing for ipconfig. So now it replies pretty quickly because I added functionality to it. Like if I just keep sending commands, you don't have to take time to wait. But if I just do like done, it will go into stealth mode and it will generate random seconds between like 10 and 80. And those random seconds, it will keep like beaconing. It will, maybe if it's 15 seconds, 20 seconds, it will send a beacon back to me. Once I'm done, I'm just going to BG or background. If you don't need it, I can just exit. And that's it. Thanks, guys.
Okay, yeah, thank you, Tarek. So next we're going to have Evan present on the Pegasus spyware, as well as talk about the NSO Group. So I will pass it off to Evan whenever he's ready.
Thank you. I'll just be
We do.
1 second.
Oh yeah, sure. So we do have a question from Michael for Tarek. He wants to know if you created the dark matter C2. Is it?
Yes, I did. Yes, yes, I did.
Sweet. So I'm just here to talk about the NSO Group and the Pegasus spyware a little bit. Some of you guys should probably be at least slightly familiar with them, just if you've ever listened to Darknet Diaries before. They've done some pretty good overviews of them, but not as much in-depth analysis on how they actually achieved what they achieved with Pegasus and its different iterations. So I just wanted to talk about that because they've been active since about 2016, and they're still currently active around the world. So just for this, credit to Citizen Lab, Forensic Architecture, and Lookout Security. I read about 120 pages of analysis, so you guys didn't have to. But they're also really cool institutions to stay up to date on like cybersecurity news and human rights, like tech news around the world. Citizen Lab is based at the University of Toronto and focuses on research and development within those intersecting areas. And they write tons of different reports on like different malware being used by governments and threat actors around the world. And then Forensic Architecture is basically the same as Citizen Lab, except they're just based at the University of London. But Lookout Security is just a mobile security company that I think most of you are probably pretty familiar with. And they specialize in providing and integrating that endpoint to cloud security with a cloud delivered platform. First off, what is Pegasus spyware? So the type of spyware is developed by the NSO Group, which is a company in Israel. And it first started out as a 0-day exploit for iPhones. Well, not just one 0-day, but 3 0-day exploits chained together. It harvests phone data from apps, calls, the camera, and much, much more, and is actually classified as a weapon by Israel. They do that a lot with their different cybersecurity companies that are producing offensive tools. And the NSO Group is known for that spyware, along with others. They say they currently deal with government clients only, but that can be a little bit sketchy because some governments around the world aren't quite nice to their citizens. Their products are meant to provide those authorized government clients with technology that helps combat terror and crime. They say they like to help like track down kids in foreign countries and stuff like that. And but they're currently embroiled in several different cases and reports over the years where their spyware has been used to target human rights activists, journalists, and more. They even potentially played a role in the murder of Jamal Khashoggi, who is a Saudi dissident journalist who came back and was murdered in a diplomatic area in Turkey. They found traces of the Pegasus spyware on his family's phones, so they had a pretty good case that he probably had it on his as well. They're currently being sued by WhatsApp, Meta, and Apple, and US companies are now, like as of 2 or 3 months ago, banned from supplying NSO with anything as they've acted against US national security and foreign policy interests by hacking employees in the DoD. So you've probably seen them featured in places like the Washington Post, New York Times, Forbidden Stories, Bellingcat, Financial Times. And so Citizen Lab initially reported Pegasus to Lookout in 2016, and they all joined forces along with Apple to look further into it. And Lookout actually came out with a full report over that initial findings. So the way that the attack actually works is a user is sent a link, whether it's through like WhatsApp or iMessage or Gmail or anything like that. And all they have to do is just click on the link, and it uses a initial exploit against Safari WebKit. And from there, it just immediately closes and basically deletes any findings of itself and uses 2 other exploits against the kernel to jailbreak the device. From there, that surveillance software is installed where persistence is fully reached and the user is basically fully monitored. It even sets up like full C2 communication and hooks all communication, starts stealing the data. And by hooking communication, I actually mean they're like listening to live phone calls. Instead of just recording it and sending it out, they're getting it like live sent back to their C2 servers. And as I said, it just looks like them getting a message from anything, just a single link, and that's all it took. And it had modules, like specific modules built into it. It didn't just grab everything on the phone, but extremely specific applications to grab messages, calls, emails, logs, and specifically targeted apps like Gmail, FaceTime, Facebook, Mail.ru for those Russian users, Calendar, and Telegram. And so like, yeah, the founder of the NSO Group says that one of the features of the exploit essentially turns the phone into a walkie-talkie. And once that spyware is downloaded, it does not actually download malicious versions of popular apps as some other mobile malware does. It compromises existing apps currently present on the phone. And iOS security prevents apps from spying on each other by kind of like sandboxing them a little bit. Very similar techniques, but on a jailbroken device, all those bets are and protections are off. So hooking is employed here, where Pegasus will then insert its dynamic libraries into legitimate processes on the cell phone. And just a throwback for anybody that like used to jailbreak their like iPod Touch 2nd generation, like back in the day. Cydia is actually used in this. They stole a mobile substrate from Cydia and kind of programmed it to do what they wanted, just to help them with the jailbreaking process. And in stage 1 of that, that's where that link is delivered and the web vulnerability is exploited. It comes in the form of an HTML file. And once the exploit is downloaded from the first stage as a packet, it is obfuscated and encrypted. This code will then exploit the iOS kernel and has a loader that downloads and decrypts the package for stage 3. And then that espionage software is installed. So stage 3 files are pretty cool. They come with like a root TLS cert, just everything you'd actually expect. But if you look further into them, you'll see things like a base library for call recording, a WhatsApp sniffer, and other things. But a lot of these were actually just stolen from like jailbroken app stores and repurposed for their use. The crazy thing though is with this chain of exploits they use to jailbreak the phones, common ways of finding out if the phone is jailbroken don't actually work. They ran through all the currently existing back in 2016 ways to check if the phone was jailbroken, and it said it was clean. So, but some of the unique findings they found with that was that the program had like super great modularity and efficiency. Similar formats were shared across the entire development framework of each tool being used in the malware, and common programming standards were used, and the program contained both debugging and QA specific functions. So these aren't just like random malware authors kind of like being paid by shady Russian people. They're like a fully functioning company in Israel that has QA and everything, like customer support for their clients. They initially called these the Trident vulnerabilities since it was 3 that were chained together. And we're going to look a little further into them. The first one was the one that exploited Safari WebKit, and it used a vulnerability to gain initial code execution privileges within that Safari web browser itself. And the second one was the kernel information link that circumvents KASLR, which Apple had implemented in their device. So before it can actually jailbreak the phone, the kernel must be found in memory. And that's the KASLR stands for kernel address space randomization, which maps the kernel into different and unpredictable locations in memory. Well, Lookout sums this up perfectly by saying before attacking the kernel, Pegasus has to find it. And Pegasus uses a function call that leaks the non-obfuscated kernel memory address and the return value, which allows the kernel's true memory location to be found and mapped for the next exploit, which is a memory corruption in the kernel that leads to the jailbreak. So after that kernel exploit, there's multiple tasks that are performed before it's ready to be really like fully jailbroken. Code signing needs to be disabled along with other kernel security protections. The system partition needs to be remounted. The Safari caches are cleared in order to help cover their tracks, and the jailbroken files are written. After that stage 3, Pegasus needs that persistence, so the exploit replaces the system daemon, which is called RTBuddyD, with a copy of a JSC binary. And then it'll create a link to a script that is similar to the first exploit that went off. But it's most likely, they didn't exactly like point it out how that worked, but most likely it's just so that it can like re-download and re-go through the installation process of the spyware if it either breaks or is removed for some reason. And other features of that is it disables any access by other jailbreaking software. There's full constant monitoring for system access, and it self-destructs if it actually detects that. The C2 infrastructure was pretty unique as well. They had multiple update channels, which were all extremely stealthy, and used SMS, which it looked like a password reset coming from like Google or Gmail or WhatsApp, Facebook, just a bunch of different ones. but they contain instructions for the new C2 server if it somehow got like pulled down or stopped working. So this is an example of that C2 SMS example. It just looks exactly like a Google verification code text you might get, but the instruction ID is the last digit of the verification code, which this one is 9. And continuing on, the SMS communication was created in case like the HTTP and HTTPS that they originally used fell through, and it allowed Pegasus to persist even when infrastructure is compromised or taken down, and is unprecedented in spyware. Looking at this screenshot, you can see that it's highly self-destructive and removes its own persistence mechanism, like removing files, libraries, like these audio recording tools mentioned here, and kills the process. Their Lookout's conclusion for this initial report was that NSO is effectively a cyber arms dealer, also referred to in their report as a cyber mercenary. And they actually advertise that they have Android and BlackBerry versions of mobile malware and zero-day exploits as well to be used, because BlackBerry was a lot more popular back in 2016, I guess. But they just recommended that devices need to be kept up to date with the latest patches, as there's nothing you can really do against a zero-day. But that's not the end of everything they've done. They're still currently at it. Through the years, I want to say about 2 zero-day/zero-click exploits were found by NSO Group for specifically Apple devices from 2016 all the way to 2021, just so that they could continue operating for their clients. Their original 0 days were fully patched by Apple, but they kept moving on because they were making hundreds of millions of dollars per year. And their malware continued to be found being used by authoritarian governments with human rights abuses through 2021. But more recently, one zero-day exploit has been used, which was called Kismet in 2020, and one zero-click exploit was used called Forced Entry in 2021, and probably still persisting to 2022 if you haven't updated your device yet, because it was as late as November, I think, was when the first sample was found. So the zero-click is the first one found being used by NSO Group, though, because the attack requires no user interaction at all to infect a device. And it's particularly unique because it can bypass the Apple security protection known as Blastdoor. And these are examples of the more recent people targeted by NSO Group, which like human rights activists, journalists, government officials, DoD employees, non-citizens, lawyers, and just random dissidents. So Kismet was used from July to September 2020 and was effective against the 13.5.1 and 13.7 iOS, and was fully patched for against in iOS 14. And just before we go into the secondary one, Apple platform security is actually pretty unique, and they do a lot to try to protect their users against these kind of attacks. They use pointer authentication codes, which are essentially a cryptographic signature on the pointer value and some additional context along with it. And before a pointer is then used, it has to be authenticated. Blastdoor is pretty cool because it screens incoming iMessage traffic for malicious data and then only passes on that safe data. It unpacks and processes the iMessage content in a secure and isolated environment. So it's kind of just doing that sandboxing before you actually get it. Then there's the page protection layer, which prevents the user space code from being modified after code signature verification is complete. So the forced entry exploit was noticed in February 2021 and is the zero-click spyware. It circumvents Blastdoor, and when the exploit was used, 2 crashes occur, which I'll go over in a second. But the first crash doesn't have as much to do with it. It just has to do with using it in the first place, but it doesn't really gain anything. It tries to render Photoshop PSD data. The second crash is the more important one because it happens when decoding JBIG2 encoded data that's present in a PDF file, which is seen in like the highlighted 1 area there. At the left-hand side, you can see that it says IM shared utilities, which is iMessage shared utilities. And it's dependent on that iMessage attachment parsing. All system modules were loaded into a fixed address, which you can see from number 2. And the crash point at 228 is within the core graphics and is that JBIG2 stream, which is reading that text region. And locating that vulnerability as per this previous screenshot, the crash occurs inside the function. Might be a little hard to read, but it'll be a little more zoomed in on the next page. That read text region of the core graphics framework. And the crash point is at line 161 of this screenshot down here. And looking closer at it, calculating numsens from the JBig2 symbol dict segment from the previous screenshot, numsens is actually an unsigned integer, and the return type of the function seg_to_get_size is unsigned as well. And numsens could be smaller than one JBig2 segment due to an integer overflow, which ends up with an out of bounds write access for the heap buffer systems, which is where this 0-click implements itself. And Trend Micro's conclusions were that common users are typically not targets of this group, utilizing the NSO Group spyware, but Citizen Lab and Amnesty Tech have identified more targets of the recent Pegasus attacks. And the attack is essentially a common file format parsing vulnerability, which should fully be patched now, if I'm correct, with the iOS 15, most recent iOS 15 update. But the key points of forced entry is that it's unknown how it bypasses the pointer authentication codes and disables ASLR. I don't think Apple's fully come forward and said how they figured it out, but they did fix the overwrite of those unsigned integers. But to fix this, concerned users that are using like iPhones can just fully block iMessage from unknown senders to fight back against it, or also just disable iMessage completely. That's just a current news segment about Apple announcing that they're fully suing NSO Group to curb the abuse of their state-sponsored spyware, since they're most popular for just exploiting those iPhones. Then some key quotes from the article. I will upload this slideshow to the Malware Club Google Drive if anybody wants to go through those articles or reports linked inside of it. But NSO isn't alone. There's tons of different companies like this all around the world, especially in Israel right now for some reason. If any of you guys have heard about Project Raven, which was run by Dark Matter, they're actually still active in the Saudi Emirates. There's also Blue Hawk CI and Black Cube, which do a lot of the same offensive stuff. And those are those links to the security reports. And that's it.
Cool, thank you, Evan. So we do have, well, does anybody have any questions either for Evan, or you could also ask any questions if you have any for Tarek as well related to his presentation.
I've got a question about you kind of touched on this at the very end, but I was just wondering what Apple and Meta's basis for suing NSO Group is. If they're just like as a human rights perspective, or if it has to do with intellectual property, or what's the basis there?
The basis is that hacking is illegal, and they're providing the tools to hack other people. They're enabling those governments to access it. They're kind of claiming that it's a national security issue, which I would agree with at the same time. This really started up when DoD employees started getting targeted. So they're enabling their clients with basically no transparency or oversight to hack into foreign countries' intelligence agencies. So Apple specifically is just attempting to protect intellectual property rights and their users.
Interesting. Okay. And then is this happening under the CFAA, or is there a global law that this would apply to, like outside of United States courts?
So Apple's suing them. They're not charging them with a crime. They're a technology company in Israel, so it'd be a little hard to charge them themselves. The United States has just ended up banning any trade or transaction with that company currently. But there's still going to be some advancements, as the EU just met, I think, 2 or 3 weeks ago and started discussing the matter of what they're going to do about it. So if the EU and the US following in technology means, I think we might finally do something about it like a year or 2 from now after they do something about it.
Interesting. All right. Thank you.
We do have a question from Abdel in the chat, and he asks, can this malware be used by other third parties or not?
The samples currently available to the public are patched for. I don't think there's any Pegasus spyware being used that works against the most up-to-date version of iPhones or iOS. Potentially, I guess you could attempt to download a sample of it and maybe reverse engineer it, but these companies sell a whole framework for it. So I think it'd be a little hard. But if you consider just foreign intelligence agencies that are paying to use it, a third party, yeah, it can be used by them.
All right, well, yeah, so if no one has any other questions, that's it for this meeting. So in a couple of weeks, we'll be resuming like on a every other week we'll have another meeting in 2 weeks from now. So that will be March 2nd. And so that meeting, we're gonna see like I might be presenting or we might have a guest speaker, but if I'm the one presenting, then we'll probably be looking at like some unpacking techniques for malware. So yeah, thank you everyone for attending, and thank you to Tarek and Evan for presenting tonight. And that's yeah, and we'll see you in a couple of weeks. See you everyone.
And as a reminder, if anybody needs to sign in, the sign-in sheet is up front.